So now we'll look at some very special types of annuities, retirement plans. There's three different types of retirement plans that we'll really be talking about, and I'll just kind of give you an overview just very briefly. They're individual retirement accounts. Two of them are individual retirement accounts called IRAs. Obviously, it's the abbreviation. And so you have two different types of IRAs. You have a traditional IRA and a Roth IRA. And a traditional IRA, what's nice about those is they're called tax deferred. It doesn't mean you're exempt from taxes. It just means that you make your payments on an annual basis without having to pay any tax on that money. So it's basically it's something that gets deducted from your adjustments for your when you do your income taxes. So it comes off of your taxable income. You don't have to account for it. So you don't get taxed on that in your income taxes. However, at the end of the time period when you start withdrawing this money, which often happens around 59 and a half years old or 60 years old, you'll start taking that money out, or you can make it last even longer than that if you want. 65 years old, I have an example here. When you start taking that money out, then you do earn tax on the amount that you withdraw from that annuity, from that retirement account. Okay, so you defer the taxes basically to the end. When you start withdrawing the money, then you earn taxes. Then it kind of counts toward your income. The Roth IRAs are similar, except you don't defer the taxes, you pay the taxes up front. So you don't get to deduct those off of your taxable income each year. You pay taxes on that amount, put it in the account, and then at the end, when you withdraw it, you don't have to pay taxes on it a second time. Okay, so it's just a little bit different way of calculating the taxes. And there's benefits and some downside to each one of those. Now there's also employer-sponsored retirement accounts, and those are often in the category of 401ks and 403bs. Just depends on what type your employer uses, and I don't really claim to know details of the difference between those or when they occur, when they don't, but can do some calculations. Anyway, in many of these, you will make some sort of investment or payment every year, and your employer will contribute. Sometimes your employer will contribute half of what you contribute. Sometimes your employer will contribute a match, like they'll match what you put in, and it's kind of a way of incentivizing people who are well trained to come work for them, right? So that the more money that your employer puts toward your retirement, the more likely you are to want to work for them. So they're encouraging highly qualified people to compete for that job, basically. That's one of the benefits to the business for contributing to your retirement. Anyway, so I've got an example set up here where you're investing $3,000 into a 401k with an employer match. So they're also investing $3,000. You're doing this every year, right? It's an annual payment. You start at age 30, so maybe you get hired in at 30 years old, and then at age 48, maybe you move on to another job, okay, another employer. And you leave that 401k, you don't withdraw the money. Now, there are penalties. You can withdraw the money before you're 59 and a half years old, but there's usually pretty steep penalties for doing so, and you lose some of that money. So most people try to let that run as long as they can. But let's say you let it ride until you're 65 years old, and then you start pulling that money out after you're retired and your income is much lower. So the question is, how much is available by the time you hit 65 if you're earning 7% interest, 7% annual interest? Okay, so let's take a look at that. We're going to use the annuity formula. You're depositing $3,000, but really it's a $6,000 payment because your employer is matching it. Okay, so we're going to say that the p-value is actually $6,000. The rate is 0.07, that's your 7%, and it's earning, you're putting those payments in over the course of an 18-year period. Okay, so T is 18, and the end value is 1 because this is all occurring annually, so we'll use the annual annuity formula. All right, so the annual annuity formula, A equals P times the quantity 1 plus R to the T minus 1 all over R. Okay, and then we just plug in everything and solve for A. So let me bring that over here where I've got a little bit more space. So we get 6,000 times 1 plus 0.07 raised to the 18th power minus 1 all over 0.07. Of course, we punch that into the calculator. 6,000 times 1 plus 0.07 raised to the 18 minus 1, and I just forgot a parenthesis. Need a double parenthesis there, and I didn't have it, so I have to go back and insert that. Very common to miss that parenthesis. Okay, so don't miss that double parenthesis right there. Close the parenthesis off, then do a divide by the 0.07. And that should, whoa, that's a decent amount. You can tell I didn't run this through before I started filming. It's 203,994.20. Okay, I was a little shocked by that value, a little higher than I thought it was going to be. Oh, that makes sense. It's $6,000 a year for 18 years, so plus the interest. So anyway, that's how much is there after the 18 years. So now the what we do with that is we just put it in, not into an annuity. The next what's that, from 48 to 65, that time period, which is what, 17 years, you're not going to be making more payments, so it's no longer considered an annuity, even though the account hasn't changed. We're going to do the calculation based upon just a simple compound interest, not simple interest, compound interest formula. Simple compound interest is not the right way to say that. Anyway, yeah, that was weird. Okay, so compound interest. So we're going to take this as our new value of P, and I'm going to change marker colors here just so it stands out. That's going to be my new P for the compound interest formula. We're going to use the annual compound interest. So I want A to be P times 1 plus R raised to the T power, where T now is going to be 17 because I want that to be the difference between the 65 and 48. So my A is going to equal $203,994.20 times 1 plus, now the interest rate doesn't change, and I got a 17 power. So that number times the quantity 1 plus 0.07 raised to the 17th power, and that is, oh wow, that's a decent amount as well. So on that one, A is equal to $644,379.97. So definitely, if you're making those investments, $3,000 a year, matched by your employer, you're going to have well over $500,000 in that account, right? That's a decent amount. Now you can imagine if you raise this up to $4,000 maybe per year, and your employer matches another $4,000, well, you're going to be well over $1 million by the end of this. I'm fairly certain. Okay. Because that interest is just going to grow and grow and grow. So these annuities are really cool. And the calculations, the idea is pretty complicated. And if you tried to do this one calculation at a time or one payment at a time and run through all that, that's a ton of work, because you've got, 18 years and 17 years, it's 35 years worth of payments to sit there and calculate and run through and add together. These formulas make it much simpler, streamlines the whole thing, punch it into one formula, you get your calculation out. So they're really neat formulas, and very useful. And you can see how, investing regularly into these savings accounts, into these retirement funds, can really, add value, to your investments over time, because of that interest that's earned. Now you could even, from this, there's other things I could do. I could find out how much interest was actually earned here. I could find out how much you contributed versus how much your employer contributed. There's lots of different things we could do with this. In fact, maybe I'll go there. Let's make a little bit of space up here. Get rid of all this red stuff, all my definitions. And let's say you wanted to figure out how much was actually interest. Or we can just break it down into how much you invested, how much the employer invested, and how much was interest. Right? You can get it all figured out. Well, if you're investing $3,000 every year over an 18-year period, that's pretty easy. It's just 3,000 times 18. That's how much you invested. So 3,000 times 18, I should know that. $54,000. Your employer matched it, right? So that's $54,000. Well, the sum total of those two is what, 108,000? So the interest is everything else. We got $644,000 here. The interest is everything but the initial 108,000 that was contributed between you and your employer. I did do that right, yeah? Yeah, that looks good. So you got a lot of interest built up there. In fact, the interest is going to be the $644,379.97 minus $108,000, right? And so that's a significant amount. Let's see. What is that? 26,379.97, right? 44 minus 8 is 26. No, it's not. It's 36. 36. There it is. 536. Yeah. $536,379.97. So that's just the interest that you earn. That's huge, right? So, so if your goal is to have, a decent amount of money saved up for retirement, or saved up, by the time you hit 60, 65 years old, why not start throwing some money aside early on? If you've got an employer match sort of thing, man, that is the way to go, is to utilize that. Because then you're not even contributing $54,000 worth of that. That's just getting paid on top of your regular salary, right? So that you're basically, your employer is giving you $54,000 and saying, here's some extra money for retirement, right? And plus you're earning interest on it. Basically half of this interest was earned on that $54,000, half of it was earned on that $54,000. So technically your employer's supplying you with $54,000 plus half of this, which is $268,000 roughly, something like that. I don't know whatever half of that is, right? So pretty cool. These amounts just grow and grow, and if that's your goal, to have some money set aside, long term, great way to do it is start investing early and get employer matches whenever possible. But definitely those IRAs and Roth IRAs are great too. I put money into an IRA, and I think it's very valuable to do that every year whenever possible. You don't have to. If you can't do it, can't do it. But to try to make that a priority, is super helpful, and you can see just from this how much that interest really does pay off over a long period of time using these annuities and these compounding interest ideas.